magnitude and direction. Let us try to understand the difference. So for example, I have a quantity like time. Now, if I'm facing towards north, or I'm facing towards west, or east, or south, if I'm facing towards north, the time now is 4, let us assume 4:10 p.m. So if I'm facing towards west, would the time remain the same or it would be different, Mr. Satya?
Sir, it would be different.
It would be different. Mr. Ariman. Mr. Ariman. Okay. Mr. Satya, let me repeat. If I check my watch and the time is 4:10 p.m. Now I am standing, the time is 4:10 p.m. Let me lie down on the sofa. What will be the time, Mr. Satya?
Sir, it would be different.
It would be different. So if I sit on the chair, the time would be?
Or again, it would be different.
Again, it will be different. Are you sitting or standing?
So certain.
Sitting. What is the time in your watch?
So 4:09.
4:09. Can you stand up?
Yes, sir.
What is the time now?
So 4:10.
Achha, you are standing and then okay. So you are standing. What is the time?
So 4:10.
4:10. Okay. Can you sit down and tell me the time?
What, sir?
Can you sit down and tell me the time?
So 4:10 only.
4:10 will be. So if you lie down on the sofa, what will be the time right now?
So 4:10.
4:10 only. If you turn upside down, what will be the time, Mr. Satya?
So 4:10.
4:10 only. So does the time depend upon the direction you are facing, Mr. Satya?
No, sir.
Mr. Aryaman, have you understood?
Yes, sir.
So there you will meet these quantities in physics where they do not depend upon the direction. Mr. Satya, any doubt?
No, sir.
So for example, a quantity like time, if you are facing towards north, west, east, south, it doesn't matter. So right now, if it is 4:10 and you turn 360 degree, it will still remain 360 degree. 4:10. Mr. Aryaman, any doubt? Now, let us take another example. Now, this is the table on which you are sitting, and let us assume that this is a pencil which is lying on the table. Now, let me see this table from above. Mr. Satya, have you understood?
Yes, sir.
I'll see this pencil from above. When I see this pencil from above, is this how the pencil will look like, Mr. Satya?
Yes, sir.
Okay. Now, if I push here, where will the pencil go?
So the
This side?
pointed side will be, yes, sir.
This side. If I push from this side, let us assume I push from this side, then the pencil will move ahead. Have you understood?
Yes, sir.
Now, if I push this pencil from, let us say, I push this pencil from this direction, then the pencil will go this side, Mr. Satya, Mr. Ariman, any doubt?
Yes. No.
No doubt.
Now, if you see, when I'm applying force, the direction matters. Have you understood what I'll say?
Yes, sir.
Mr. Ariman, have you understood?
Yes.
So in physics, you will meet two kind of quantities. The first example that we have taken is time and force. In time, only the magnitude matters. What is the meaning of magnitude? Magnitude implies what is the quantity. So for example, the time is 4:10. In force, you will require the magnitude, how much amount, how much, basically magnitude means how much, as well as the direction, For vectors, you need two things to be specified, but for scalars, you need only one thing to be specified. Mr. Satya, any confusion till now?
No, sir.
So this is factor A, this is factor B. Let me take another example. So for example, Mr. Satya, do you know what a thermometer is?
Yes, sir.
Mr. Satya, what do you think? Thermometer would be a scalar quantity or a vector quantity? Mr. Satya. Mr. Ariman.
So,
Yeah, Mr. Satya, you want to answer?
sir, I think it would be a scalar only.
Okay, okay. Mr. Ariman,
I think it will be a vector
it will be a vector. Mr. Ariman, why will it be a vector?
because
And yeah.
how much you need how much,
Okay.
and you will also actually you only need how much. There won't be direction.
Mr. Satya, any doubt?
No, sir.
Mr. Ariman, have you understood?
Yes, sir. So whichever. So if it needs any of the two factors, then it's a vector, and if it doesn't, then it's a scalar.
Shabash. So for vectors, I require how much as well as direction. Which direction? Mr. Satya, any doubt?
No, sir.
Mr. Ariman, any doubt?
No, sir.
Let me take few more quantities. Okay, let us discuss these first. Mass and volume. Mr. Ariman, what do you think?
Mass is scalar, volume is
Yeah. Mr. Satya?
So, I think volume would be.
अरे भाई घबरा क्यों रहे हो कुछ भी बोलोगे कुछ भी बोल लो यार
So it's vector, I think.
Okay, y vector. Y vector.
So because first, so we are doing how much?
Okay,
Then
how much? So how much is required in both the quantities? I think that is pretty well understood. Now we need to the confusion that we are having is, do we require a direction or not? Mr. Aryaman, am I correct?
yes.
Okay, so what do you think?
So I think both are scalar.
Both are scalar. Mr. Satya, what do you think?
so even I think because we don't need direction in any.
Okay, let us take a simple example. The volume of this bottle, of this milk bottle, is 1 liter. Now, is this enough, or do you require the direction of this bottle also?
We don't need direction. So
Mr. Satya, what do you think?
So we don't need direction.
So, should we say both of them are scalar quantities?
Yes.
Mr. Nariman?
yes, sir. Both are scalar.
Yeah. Is it clear enough?
Yes, sir.
Mr. Satya, do we have any doubts still?
No, sir.
So, this is scalar, and this is also scalar. Any doubt?
No, sir.
No, sir.
Okay. Now, see, there are a bit. There are quantities, simple quantities that we have discussed till now. So, for example, we have discussed time, we have discussed temperature, we have discussed. Yeah, Mr. Arman, any doubt?
Yes, sir. Can you give us one example of a vector apart from?
Sir, I'm just giving you the example of vector. The only problem is you will understand the problem. So the quantities that we have discussed till now are time, temperature, volume, mass. Let us take another example. Let us take an example of area. Mr. Satya, what do you think?
Sir, it would be vector because we need how much it is, and we also need the direction.
Okay. Why do you require direction for finding area? So this is my rectangle. This is 3 meter. This is 2 meter. Do you require direction also?
No, sir, I think.
Mr. Rariman, do you require?
You don't require direction.
So, Mr. Satya, it would be a
Scalar.
scalar. Let us take another example, density. Mr. Satya.
Sir, I think it's scalar only.
It is scalar only. Mr. Rariman.
It's scalar.
It is scalar. So are we okay with scalars?
Yes, sir.
Yes, sir.
Now let us come to vectors, and I think you'll understand my problem now. So the first quantity I think that we have understood is very easily what we have understood is force. Any doubt about force?
No, sir.
Yeah. Now there are two things that you will need to understand. Let us take a simple example. Speed and velocity. Now I'll write two things. 3 meter per second. 3 meter per second towards north. I'll write 3 meter per second towards south. I'll write 3 meter per second towards east. Mr. Satya, what do you think about this quantity? Is it scalar or vector? 3 meter per second.
Sir, I think it's vector.
Okay, it is vector. Why it is vector?
So because in this we are measuring the, like, it is how much also, and direction. Yeah, direction also, sir.
Have I mentioned
Because
the?
it's, yeah, sir.
Have
We
I
have
mentioned?
written there.
Oh, okay. This is first. This is second. This is third. This is fourth. So the first quantity, is it a scalar or a vector? With the information that I have provided.
It's a scalar.
Scalar. Mr. Araman, any doubt?
No, sir.
Now let us come to the second example. Mr. Satya, it is a scalar or vector?
It's a vector.
Vector. This quantity, Mr. Satya?
It's a vector.
This quantity, Mr. Satya?
Vector.
So please understand that 3 meter per second, if it is only 3 meter per second which is provided, this would be called as speed. But if, so this is a magnitude only. If magnitude plus direction is given, this would be called, Mr. Araman?
Force.
Velocity. Any doubt? Velocity. Velocity. Mr. Araman, any doubt?
No, sir.
So let us see this again. Speed, velocity. We have called speed scalar. We have called velocity vector. Why? Because in speed I require magnitude only, but for velocity I require magnitude plus direction. Any doubt still?
No, sir.
No, sir.
Let me take another example. 3 meters, 5 meter towards south, 15 meter towards north, 10 meters. So this is the first quantity I have mentioned. This is the second, this is the third, and this is the fourth. Mr. Satya, first quantity would be?
It's a speed scalar.
I'm sorry, this is 3 meter. This is distance.
Okay, sir.
So this quantity where only magnitude is given, this would be?
It's a scalar.
5 meter towards south. This would be?
Vector.
5 meter toward north. This would be?
Vector.
10 meter.
Scalar.
So here we are discussing two kind of quantities. The first quantity scalar is called distance, and the other quantity where magnitude as well as direction is given is called a displacement. Any doubt?
No, sir.
Mr. Ariman, any doubt?
No doubt.
So I repeat, scalar quantities and vector quantities. Scalar quantities require magnitude only, magnitude only. Vector quantities require magnitude as well as direction. Sir, any doubt?
No, sir.
Mr. Ariman, any doubt?
No, sir.
So, Mr. Satya, have you understood the difference between scalar and vector?
Yes, sir.
So, mass is a scalar quantity. This means that you require only magnitude. You require only magnitude. So, for example, you will say 5 kg. So, the 5 kg, because only magnitude is given, it is a scalar quantity. Now, in last lecture, what we have understood is that weight, definition of weight is, it's the force with which Earth attracts a body. Mr. Satya, do you agree?
Yes, sir.
Now, because it is a force, and we know that we have defined force as a vector quantity, that is why weight would be called
Vector.
Mr. Ariman, any doubt?
No, sir.
Mr. Satya, any doubt?
No, sir.
See, please try to understand. We have called weight. We have called weight as force. We have discussed that force is a vector quantity. Because it is a vector quantity, then weight will also be a vector quantity. And if you ask me, sir, what will be the direction? So let us take a rough diagram. So if this is Mr. Satya standing on Earth, then this is the direction. This is the direction in which his weight, which is a vector, is pointing. Mr. Ariman, any doubt?
No, sir.
See, vectors are represented by a arrow. Vectors are represented by, you will do this in maths also. I think in 9th class you will do this. I don't know whether it is there in 8th class or not. Most probably this will be in 9th class. So vectors are represented by arrows. They have magnitude. So this length of this vector, the length of this vector will give you the magnitude of the vector, and this direction will give you the, of course, the direction will give the direction of the vector. So I can have a vector like this, or I can have a vector like, I can have a vector like this, I can have a vector like this. Mr. Satya, any doubt?
No, sir.
So usually vectors are discussed in detail because this was shown in your school. That is why I'm just discussing it. But I think you'll have got a fair amount of idea of the difference between scalar and vector. Mr. Ariman, any doubt?
No doubt.
So mass is a scalar quantity, kg. Weight is actually force, and the unit of force we had discussed last time is Newton, and therefore what we call ki what is your weight, तो हम बोल देते हैं it is 50 kg, या हम बोलते हैं भैया कितना weight हुआ, तो हम बोल देते हैं 30 kg. That is actually incorrect. Mr.
Yes.
Satya understood?
Yes, sir.
Because all weight is in Newton. Mr. Satya, any doubt?
No, sir.
So it is in common language that we say, and that is what we were discussing here. In common language, we do a lot of mistake, at least from a physics point of view, because I think here you would have understood that there are 2-3 things that the common mistakes that we do. The common mistakes that we do is speed and velocity. In common language, we say that they are same, but now we have understood that speed is a scalar quantity and vector velocity is a vector quantity. Mr. Araman, do you agree?
Yes, sir.
Mr. Satya, do you agree?
Yes, sir.
Similarly, what we discussed was that distance is a scalar quantity. Distance is a scalar quantity, and displacement is a vector quantity. Mr. Araman, do we agree?
Yes, sir.
So the common mistakes in, at least from a physics point of view, that we do in daily life, we consider mass and velocity, mass and weight to be the same. They are not same. We consider speed, velocity same. They are not the same. We consider distance and displacement the same. They are not the same. Mr. Araman, any doubt?
No, sir.
Mr. Satya, any doubt?
No, sir.
So this is scalar and this is vector. Now, what you need to understand is, another thing that you need to understand is, here even the units are different. Here the mass is kg, but weight is in Newton. But what you need to take care is that the units of speed is meter per second, MK system that we had discussed last time. The units of velocity are meter per second. The units are same. Similarly, distance is meter, displacement is in meters. The units of these two quantities are same. Have you understood what I'm saying?
Yes.
But इस case में mass and weight have different units. Mr. Ariman, any doubt?
No, sir.
Mr. Satya, any doubt?
No, sir.